Hello, Year 8. Today we are going to be finding the rule using a table of values. But before we do that, we have a revision box up here to revise what we were doing last lesson, which was horizontal and vertical lines. So on the grid paper that's here, the first thing you'll need to do is to draw up your Cartesian plane. So you'll need to draw a vertical line as close as you can to the middle, and a horizontal line approximately in the middle. And then we need some numbers. So positive numbers going to the right, negative numbers going to the left, positive numbers going up, and negative numbers going down. So this is our x and our y axes. So there are two types of equations. We either have x equal equations or y equal equations. If we have y is equal to 2, that means that we want a horizontal line going through the y-axis at the 2. So y-axis, this is my y-axis here, and that line is going through the y-axis at 2. So that's, put some arrows on the end, that's the first graph for A. It doesn't matter how long the line is, as long as it's a line, and it does have arrows on the end. Now the second one is y is equal to 4. So that's going to be going through the y-axis again, but this time at the number 4. Okay, so that is graph for B. Part C is y is equal to negative 3. So we come down to negative 3 on the y-axis, and we draw a line going through y equals negative 3. Okay, what's next? We have y equals negative 5. So move down to y equals negative 5 and draw a line going through. So all the y equals graphs, so this was C and this was D, are horizontal lines going through the y-axis at the number that you're given. In question E, we are now switching to an x equals equation. If it's x equals 3, that means my graph needs to go through the x-axis at the 3. So this is going to be a vertical line. There it is, going through at x equals 3. And the last one, x equals 4, just move it over a bit, going through the x-axis at 4, another vertical line, and that one is F. Okay, so that is vertical and horizontal lines. Don't forget about those. Let's have a look at our new work for today. So we want to find the rule using a table of values. Now we know that straight lines have equations in the form y equals mx plus c. If you're looking in older books, it may say mx plus b. Doesn't matter which letter you really use there on the end. The m is the gradient, and the c is the y-intercept. Now, if you have a table of values, you just need to find the gradient and the y-intercept, and then you can write your equation in that form. So, if we are looking at these tables here in question 1, I want to find the gradient and the y-intercept. So the gradient is what the numbers across the bottom here are going up by. So you might want to look at these last two values here. They're nice positive numbers, and you can see that that's going up by 3. And all of them, as you go across there, they're going up by 3. So that's how much your graph is rising by each space. That is your gradient. So your m is equal to 3. The y-intercept is when the x is equal to 0. So x equals 0 is right here in the center of my table, and the y value is the -1. So whatever is underneath that 0, so in this case the -1, that is your y-intercept. Okay, so once you've found those values, you want to put them into the y equals mx plus c. That means I'm going to have y equals, m was 3, so it will be 3x, and c was -1, so -1. And that is the rule that we're trying to find, y equals 3x minus 1. Let's try that again a few more times. In part B, we want to find the m and the c first. So going across the bottom here, what are these numbers going up by? Again, they're going up by 3. So that means m is equal to 3. Underneath the 0 is a 1, and that is my y-intercept, 1. Putting those numbers into the y equals mx plus c, I would get y is equal to 3x plus 1 this time. And that's my answer. Okay, question 2 is the same thing. It says find the rule for the following tables, which means find your gradient, find your y-intercept, and put it in your rule. So for part A, m and c. So what are these going up by? They're going up by 1 each time. So that means my gradient is 1. My y-intercept is the number underneath the 0, which is -3. Putting that in the y equals mx plus c formula, we get y is equal to 1x, which we can just simplify that to be x, minus 3, because c is a -3. And there's my answer. B. Let's find the m and the c. So going across the bottom, these numbers are going up by 2. So that is the m. Underneath x equals 0, we have y is equal to 0, so c is equal to 0. Putting that in our formula, y equals mx plus c, we will have y is equal to, m is 2, so it'll be 2x, and then plus 0, but we can just leave that off because 0 is 0, so it's just y is equal to 2x. Part C, m, these numbers here going across, they're actually going down this time. Normally they go up, so this one's a special one. If they're going down, that means I'm going down or minus 2. They're minusing 2 each time as you go across. Then I need to find the c, so underneath the 0 we have a 2, so that is equal to a y-intercept of 2. Okay, then putting it in our formula, y equals mx plus c, we're going to have y equals -2x plus 2. Great. Okay, one last one. This is a bit more of an application because we don't always have to have x and y. Our graphs can represent other things. So this information here is obviously time is passing, and we've got some savings in dollars, and we want to find an equation of what is happening there. So sticking to our process, as we go across the bottom here, these numbers are going up by 50. So it's going to be m equals 50, and c, the number underneath the 0, which happens to be all the way over on the left-hand side this time, c is going to be equal to 20. In our formula, y equals mx plus c, we're going to have y equals 50x plus 20. Okay, and that's it. So instead of x and y, though, I should change that into the words that are on my diagram here. Instead of y, I actually have savings. So savings are going to be equal to 50 times by the time, and then plus the 20. So that's just using the words in the table instead of the x and the y that we're used to. All right, so time for you to practice Your questions start here on the next page.